So in this lesson, we're just going to look at some more applications of Pythagorean theorem. Now, if I was to go to your textbook, I would have to send you to multiple pages in order to get enough examples. So I'm going to stick with just a few examples that I've pulled. I've tried to reference page numbers, so if you're having issues reading the text, you can look them up. I've put a note on the bottom of your pages. But I think they've copied quite well, but that way at least they are referenced for you. So our goal today is using Pythagorean theorem to solve for side lengths, the same as we had last day, but we're going to apply it in some trade context, in particular looking at layouts. Now, what we're going to start with first is a little review question. So I want to find, I have the length, sorry, it should be the measures of angles 1, angle 2, and angle 3. So we've got our little angle symbol here, angle 1, angle 2, angle 3. Now when you have a question like this particular one, don't think you have to solve them in the order 1, 2, 3. Look for what's easiest to solve, and oftentimes there's more than one way. So the big principle to remember here is angles in a triangle. I gotta remember to switch my ink color. Just give me a moment. Okay, so the angles in a triangle sums to 180 degrees. Okay, so a triangle sums to 180 degrees. So what I always like to start with is I'll look at my diagram. What angles do we know? So we know we have a 90 up here in this corner between this edge and this edge. Down here we have a 90 degree, and because it's connected to a straight line, that means there's a 90 degree over here as well. So now we can use that to solve. We have two triangles, actually I shouldn't say we have two, we have three triangles. We have this little tiny triangle, we've got the middle-sized triangle, and then we have a very large triangle. So we can use all three of those to help us solve. Now you may solve this in a different order than I will. That is perfectly acceptable. You should get the same answers, and I encourage you, if you see something different than what I see, pause the video, try to solve it, and then come back and see if you're getting the same solution, even if you're using a different method. I'm going to solve angle 3 first, simply because I find it really easy to look at this little triangle. So for angle 3, I have a small triangle. I know that the angles all add up to 180. So 180 is equal to 79 degrees, 90 degrees, plus angle 3. So the way I solve this one is I say angle 3 is equal to 180 minus 90. You might have noticed that if you have 180 in a right angle, you're just left with 90 degrees. So you could just do 90 minus 79. That would be fine. That's just skipping a step ahead. Minus 79 degrees. And you will find you get an angle that is 11 degrees. Okay, so that's angle 3. I like to go back in, and that's why I kind of switched and not had white ink, and pop it back in here. And I'll say, well, this angle here is 11 degrees. That makes it really easy to find angle 1, because we know angle 1 plus angle 3 have to add together to equal 90. That tells us angle 1 is equal to 90 minus 11 degrees, which gives us angle 1 equals 79. Right? So that gives us our next one. Now we're just left with angle 2. Angle 2 is nice and easy to solve. You don't really have to do math for this. I am going to do the math out because I want you to think about the process in other situations where this may not hold true. But you'll notice here you have a 90-degree angle, we have a 79-degree angle, and an unknown angle. This little triangle over here also had a 90, a 79, and an unknown angle. So we should find we get the same 3 angle measurements for the larger triangle and the smaller one. The way I think of it, I just think of it, okay, to get angle 2, it's equal to the total sum of the angles, so 180 minus the angles that I know. So I know there's a 90 in the corner, so I've used this one up. I know there's a 79 up at the top. So we find angle 2 equals 11 degrees. So that's just reviewing the property of triangles in the context of the sum of all of the angles in a triangle will always equal 180 degrees. You're going to come back and you're going to use that on a regular basis. Now let's go forward with Pythagorean theorem. So just a quick reminder, Pythagorean theorem is the formula a squared plus b squared equals c squared. C is always the hypotenuse, and it's always opposite the right angle. I would suggest labeling that side first, but you can only use this if you have a right angle. So we need to make sure we have a right angle before we even try to use it. That's very important. So for our first question, this is very similar to what you had last day. We want to, first of all, determine the center-to-center distance between holes A and B. So starting at hole A, there's our center for A, down to the center, center for B, down to the center of A, or you can think of it the opposite direction. It's also labeled as length C. So in order to find the center-to-center measurement, I'm looking for what's the distances on the other side. So we are looking for the hypotenuse here. It just happens to be labeled with A, B, and C in the right places. So a squared plus b squared equals c squared. Putting numbers in, we have 6.027, and this is all in inches. I apologize, sometimes I haven't transferred the units when I've copied the image, so hopefully that doesn't make things an issue for you. I am going to leave the units out when I write it in my equation, only because when you start putting inch symbols and squared symbols together, I find it clutters. So I'm hoping that'll make it more clear for you. So we have A is 6 and 27/1000. So square that plus 8 and 139/1000 squared equals c squared. Now, I haven't told you what to round to, but you'll notice each of your questions, each of your numbers have 3 decimal places. So I strongly advise you to maintain 3 decimal places. That would be the precision of the question. Therefore, we're going to give our answer at the same precision. You can do this in one step in your calculator. Give it a try, see if you get the same number. 6.027, press your squared button, plus 8.139, press your squared button and make sure you hit equals. That's really, really important. You should find for your answer, you get 102 and 519,000 equals c squared. Now when you get this is not c. This is not the answer for 1. What we need to do is we need to take our square root. If you take the square root, that will give us our final answer for distance C, which was 10 and 125,000. And it was in inches, so we're going to put that back into inches. Okay, so that's our answer for 1. The answer for 2 is a very easy answer, but I asked this one because if you have a part and you're checking your specs, you can't measure center to center on a hole, but you could take a measurement edge to edge on the inside. Okay, so that's what we're really looking at here. As I'm looking for, if you were to start here and to start here, what would the distance be between the edges of the hole? Something you can measure with a caliper. Well, all we have to do is subtract the radius of radius of hole B and the radius of hole A to get our answer. If we go back to state question 2, it says if A and B have a diameter, so they're the same, of 235,000, what is the edge-to-edge measurement? Because both holes have the same diameter and same diameter and we need to subtract 2 radiuses, really it's the same as subtracting 1 diameter. If the holes were different sizes, we'd have to think about, well, what's the radius of this hole and what's the radius of this hole, subtract them separate. But in this case, we don't have to worry about that. We can just subtract 1 hole. So we're going to take our, I think I may have to work on editing colors here. All right, so we're going to take our 10 and 125,000, And from that, we are going to subtract the diameter of our hole. We can subtract the diameter because both radii are the same. Okay? And that gives us an edge-to-edge difference of 9 and 89 hundredths, or 9 and 890 thousandths of an inch. And that would be our answer for B. Okay? So relatively straightforward, fairly simple. Just thinking about those hole sizes is one of those things that's maybe it makes you think a little bit. Now, as far as the textbook, what it asked you to calculate, it didn't ask for that hole-to-hole measurement. So you'll find on some of these, if you are looking up questions, you may find I've modified them a little bit, but used the same diagram. It also tells you where you can go if you want to find an example in the book, should you have the book at home. Let's do another example. In this one, I want you to use the properties of triangles to find angle 1 and length x. Then we want to calculate the height of the triangle in inches and the area of the triangle in square inches. And we're going to assume that all of these measurements are given to us in inches already. So when I look at this triangle, first thing you kind of look at it, you go, okay, what is angle 1? Well, we don't really have a lot of information to tell us. So we'll look at it, and I look at it and I say, well, this side and this side, they're the same. Because these two have the same length, so two sides the same and one side different, this is an isosceles triangle. I'm not going to spell that because I'm going to mess it up, I know. That's just one of my flaws. But with an isosceles triangle, this angle and this angle, the two angles connected to the two matching sides, are going to be equal. So because it's isosceles, we can say angle 1 is equal to 38 degrees and 40 minutes. Angle 1 equals the angle on the other side. It's symmetrical. Because it's symmetrical, that also means that x is equal to 18.4 divided by 2. Just split it in half. If we didn't know these two sides were the same length, we could not do that. But because they're the same length and it's a symmetrical isosceles triangle, we can just divide by 2 to get x. That's the distance to our height, from the edge to the height, or using the base. And that's going to give us 9.2 inches. You could keep an extra decimal if you want. This 18.4 only has one decimal place. So here I would argue you could keep one decimal or 2. You don't need to be more precise in the question. So that's our angle 1, and that's our measure for x. 2, calculate the height. So my height of this triangle is here in the center. Okay, so in order to find the height, what I often say is we can only use Pythagorean theorem if we have a right triangle. So we can't use this whole triangle because it's isosceles. The right triangle comes when we split it in half. So we're going to look at just half the triangle at a time. That's all we really need. So we have our height. We know that this side is 12.4. We know that the base we calculated is 9.2. So in order to calculate it, we'll use our formula. A squared plus b squared equals c squared. First of all, find where is your c. So this side is our c. That's our hypotenuse. So if I put this into our calculation, I get h squared plus 9.2 squared equals 12.4 squared. Rearranging that, you will get that h squared equals 12.4 squared minus 9.2 squared. Subtract 9.2 from this side, subtract it from the other side. Now, I'm going to trust that you can put this in your calculator. Don't forget to press equals at the end. Putting that in your calculator, you should get an answer of 8.31 inches for your height. Okay? And that answers the second question. The third question is just as easy. So to get our third question, it wants to know the area. Think back to your first semester, and we didn't spend a lot of time with it, so you might have to look it up. Area of a triangle is equal to base times height divided by 2. Remember we said that the height has to be 90 degrees to the base? So in this case, the pieces that we're interested in, my base I'm highlighting in red, and I'm highlighting the height in red. So we're finding the area of the whole triangle. So the whole base and the whole height. So we can kind of go back to the original. The height for the big triangle is the same as the height we calculated for the half triangle. So putting that information in, we get 18.4 times 8.31 divided by 2. And if you put that in your calculator correctly, we would get 71.45. And I'm going to write the inches squared down below because I'm running out of space. Ran out of space so much it went to the next slide. Okay, so that happens to be our answer. So hopefully that wasn't too tricky. There's a couple practice questions that use some of that math, but we're going to be kind of looking at pulling out multiple pieces. How do the different pieces interact with each other? Example 3, I again want you to use properties of triangles to find lengths x and y. And then I want to calculate the horizontal width of this figure. By horizontal width, I'm starting from point B, and I want to end over here. So the distance the whole way across. I'm not sure why I get that little screen pop up. I think it has to do with pen pressure on my tablet, so I'll have to work on that. All right, so the first thing we're going to do is we're going to find lengths x and y. Well, how do you do that? Because Pythagorean theorem says we need to know 2 lengths in order to find a missing side. And in this case, I only have 1 distance. Well, what I start with is I look at the angles in the triangle and see what kind of triangle is this. If it's isosceles, there's going to be angles that match. If it's an equilateral, there's going to be angles that match, and that's going to give me information about my sides. So here, we know that this angle is 60 degrees. We know the angle over here is 60 degrees. And because of that, 180 degrees minus 60 equals 60. So we have an equilateral. Equilateral. I don't know if I left an I out or put too many I's in or got too many A's. I usually do one of the 3. So bear with me. But you know what I'm trying to put down. There's certain words that I really do struggle with. It's one of those things that practice doesn't seem to be taking it out of me. I struggle with combination letters on some things, especially if there's a lot of the same letter. So because all 3 angles are the same and it's equilateral, all sides are equal. This means that x equals y, because all sides of the triangle are equal. So this side is equal, that side's equal, and they all equal 118.30. And I'm not sure whether this diagram was in inches or millimeters. Let's say it was in millimeters, and we'll go with millimeters. I apologize for that. All right, so that answers our first question. We've got that one done. Now question 2, the horizontal width. So just to highlight it for you again, I want to find what's this width all the way across the middle. Okay? So how do we calculate that? So the first thing we do is we look for a right triangle, and because of the way these intersect through the center, we get a right angle right here in the middle. So I can look at this triangle this way. And using that, I can put in, well, I know this is 118.3. And then we need to figure out, well, what is this length? I don't know what it is. To figure out this height, we know the length of y is 118.3. So this piece in here, I can say that's 118 0.3 divided by 2, which is going to leave us with a height of, I have 59.15. Okay? Now, I like to sometimes draw a separate triangle out because it helps declutter the image. You don't have to. You could sketch that particular image, but I often will pull things out separately just so that it can declutter and hopefully make it easier for you to see. That's a good strategy to use. Even sketching a diagram bigger so you have space to write things in is really, really helpful. So for you to have paper on hand when you're working through these is really important. So we have two sides. We want to know a third side so we can put them in. Now this is my hypotenuse because it's opposite the right angle. So that's my C. So we know that x, I'm going to call it x squared is equal to, oops, I shouldn't say equal. Let's, I could write it that way, but for the sake of consistency, I'll use the regular formula. X squared plus 59.15 squared equals 818.3 squared. You can leave off the extra zeros if it's easier for writing, that's absolutely fine. X squared is equal to 118.3 squared minus 59.15 squared. If you put that in your calculator, again, I'm trusting that you now know how to do that. If you need time to do it, pause, put it in your calculator, make sure you're getting the same answer. You should get an answer of 10,496.18. Okay, and that will give us an x equal to, so you take the square root, and then after you've got your square root, you're going to find x is a length of 102.45. The distance, the width, is two of those. It's a symmetrical figure. We've got a distance here and a distance on the other side. So because it's symmetrical, the width is equal to 2 times 102.45, which gives us 204.90. And we're going to say, I said this was a millimeter, so since it's in millimeters, we'll throw our millimeter symbol in. And that gives us our answer for 2. All right, for this particular image, we have 3 holes set out in a layout. So what we're looking for here is we're trying to figure out what are the distances between hole centers to solve this particular triangle. So we're looking for distance C and distance D. We already know this edge because it's related to the radius of the particular circles. We're going to need that information to help us. So one of the first things I look for is where's the right angle. Right angle, there's going to be a right angle down here at the corner. Okay, so this is a straight line connection, so there's a right angle here and a right angle on the other side. To solve this question, break it into 2 triangles. So let's do C first, simply because it's the first in the alphabet, for no other reason that you could do D first as well. And I'm going to draw out the right triangle with the information that we need to have. Okay, so there's our right triangle. Now, this particular height is related to the diameter. So because this is a radius, to solve it, we're going to take our diameter, 72.4, we're going to divide it by 2, and that distance is a radius that is equal to 36.2. Okay? Now we go across the bottom. So what's this bottom measurement? Well, it doesn't look like it's there, but you'll see here it gives us a horizontal distance of 95 millimeters. And that's that distance from the center of hole A to point T. So we know our bottom is 95 millimeters, which lets us find out what is C. So we'll substitute that into Pythagorean theorem. So this is our A, this would be our B, this is our C, this is the hypotenuse. So we have 36.2 squared plus 95 squared equals, and you find out what your C is. So that's going to be equal to c squared. Put all of this in your calculator. See if you can do it in one stretch. This is one where the numbers get large, so I like to do it in one piece so I don't lose anything. I get 10,335 and 44 hundredths is equal to c squared. Then we take our square root. That leaves us with c equal to 101 and 66 thousandths of a millimeter. Once you've done C, D is really easy because it's exactly the same kind of question. So to find D, I'm running out of space, but we'll squeeze it in. So D, same triangle, but it's just flipped down. So I'm going to flip it up just because it fits. So this diagonal distance is distance D that I'm looking for. Down here, we still have, 95. They share a side. And then this vertical distance, so this is my distance right here, it's equal to 30.8 millimeters divided by 2, which will give me 15.4 millimeters because it's a radius, it's half of the whole. So this is now 15.4. Now I can calculate, we're going to go exactly the same equation we had up here. So 15.4 squared plus 95 squared equals c squared. Solving that in our calculator, you are going to get 9,200. Excuse me, I don't know what's going on with this little glitchy thing. 262.16 equals c squared, and c is equal to, and I'm just using A, B, C. You can switch that, we could switch that letter to D. So C equals 96.24, which is equal to measurement D. So if you're handing this in for an assignment, you can use the a squared plus b squared c squared. You can use those letters, but make sure when you give your final answer, just relabel it as D. And maybe I should have done that as I went through. So if you'd rather adjust those to be D's, you can. Sometimes I just think about the formulas a squared plus b squared equals c squared, and I substitute in where I know the information. So hopefully you didn't find that one too bad. I think I've got one after this, and then we'll be finished. So this one again is a nice straightforward calculation. So we want to find measurements A and B. So I'm looking for the measurement here and the measurement here, given the diagram provided. So in order to calculate this one, let's look at the triangle and see what information. First of all, I notice it's not a right triangle, but we can make it a right triangle quite easily. We're going to just put a vertical line through. There's our right angle. Now, two sides of this triangle are the same, and if you remember your definitions before, that means this triangle is isosceles. So when we put that vertical line through the height, it divides it perfectly in two. So that lets us figure out what is this distance. And in order to figure that out, in order to figure out the length of this distance, because we're going to need it for the whole triangle, we're going to take our overall length, center to center, I'm going to divide it by 2. So 30.2663 divided by 2 leaves us with a measurement of 15.132. So that gives us that measurement. Now that's going to let us do some calculation. So when I'm calculating this one, think about which one's the easiest one to solve. So I look, okay, what do I need in order to figure out A? Well, A is the distance from the middle to our center of the hole and then to the edge. So we have everything we need to calculate A. So to find A, it's 7.000 plus 15.132. This leaves us with A equal to 22 and 132 thousandths of an inch. So that's not too bad. Now I want to figure out, well, what is B? In order to find B, I know the height from the center of this top hole down to the bottom of the block. I need to be able to subtract this measurement. That's the same as the height of our triangle. And we do have a formula that we can use to calculate that. So we can use Pythagorean theorem. So our triangle that we're looking at, in order to find the height, I'm going to call this X just because I'm looking for it. We have 18.090 and I have 15.132. In order to find X, we put it into our formula. So a squared plus b squared equals c squared. 18 is our c. The 15 could be either a or b, so putting it in. 18, right. I'm always afraid if I flip orders, even though you're allowed to do it, I don't want to mess somebody up, so let's switch back. So a squared or x squared plus 15.132 is equal to 18.090, and we've got to put squares on each of those. Rearranging it, a squared is going to be equal to 18.090 minus 15.132. Solving that, you will find that a squared is equal to 98.271 inch. That's, I'll leave the symbol off. It's going to be square inches, but I don't want to confuse you with that, so I'm just going to leave that out right now. And then we'll take our square root. And a is equal to 9.1913. Back to my page, inches. Inches in gives us inches out. So this height we can say is 9.913. Well, now we can calculate B. In order to calculate B, I'm just going to write it here on the diagram. I may switch my ink so that you can follow it. So B is equal to 17.823 minus 9.913, which gives us B equal to 9,910,000. Okay, so not difficult, just there's a bunch of pieces. And you're going to be looking for that. This is going to push critical thinking. Some people find this fun, they'll find it easy. I enjoy doing this, but I'm a nerd. Some of you I know will find it a little bit more challenging, and that's okay. That's perfectly okay. We all have things we find easier, and we all have things we find more challenging. Last question. In this question, I want to find, this applies to if you're drilling a hole diagonally through a block, you want to find this information. There's a whole chapter in your book that deals with it. We're just going to do a couple of examples and just look at it from a Pythagorean theorem perspective. We'll probably revisit this later once we've solved angles. So maybe towards, not next week, but the week after, we'll probably come back to this and you'll get a second chance at it. So I'm going from point A to point B, and we want to figure out, there's my whole line. We're doing a diagonal drill through a block, corner to corner. We want to know, what is that distance going to be? So in order to find that, we need to find our right triangles, and this diagram has the right triangles drawn for us. So there's one right triangle vertically. It uses the height of the block and the diagonal through the bottom of the block. We don't know this diagonal if you're just given height, width, length, width, and height, and figure out which one you want to call which. But we can calculate it using the length and the width by using a triangle on the bottom to find the diagonal, and then just including our triangle heights. We really have two triangles to solve in order to get this. So first we're going to figure out what's the distance between C and B. And the way I'm going to write that is I'm going to call it line CB. So line CB, to write that, we'll often just write it with a C and a B written side by side. So that would be the way, that's the way in most textbooks you'll find they'll write CB. So in order to calculate this one, I cheated. I took the easy question. I'm giving you the trick here. There's my triangle. This length we'll say is equal to this side here, and it's 3.00, but we don't need to write the zeros in for the solution here. We'll just make sure we put them in our answer. And on this side, we have a 4. I want to know, this is line CB over here. Okay, so there's point C, and there's point B. So if I want to find CB, I use my Pythagorean theorem. So a squared plus b squared equals c squared. And c in this case, our hypotenuse, is line CB. So that's what we're looking for. So 3 squared plus 4 squared equals c squared. And hopefully you recognize that we have a 3 and a 4. This makes the Pythagorean theorem triple. So you might not have had to do any math if you happen to know that by heart. But this is 9 plus 16 equals c squared. So 25 equals c squared. We take our square root, and c equals 5. So we can plug that in right in there. Now we have a new triangle. This will give us AB. So now that we have that, we can actually find what we want. Triangle AB is the vertical triangle. It has the diagonal CB as its base, and we see that over here. So it's going to be 5. And then it has the vertical height equal to the height of our block, which is 2. So we just put the information in. AB is this side right here. So it's whenever I do circles. This will be the way I write. So the distance from A to B is going to be found by going 2 squared plus 5 squared equals c squared. So we get 4 plus 25 equals c squared. 29 equals c squared. I like doing mental math periodically rather than just putting it in the calculator. And take our square root of each side, and c is equal to 5.385 inches, or 5 385 thousandths. Typically when you see 3 decimal places, you can assume it's in inches, even if I haven't stated. And that's equals the distance A to B. There. That covers all of our examples. So a few challenging ones, a few that hopefully are a little easier, but that gives us everything we need. So for a quick lesson recap, use the properties of triangles to help you solve for missing components. So look and see, if it's isosceles, it's symmetrical. If it's an equilateral, you have all sides equal, even if they're not all labeled. Identify hidden right triangles. So sometimes you want to extend the lines beyond a diagram. In most of our cases, we found a triangle inside of the diagram, but you could also find a triangle outside and think about how would I find those pieces. I'll post a video solution for the worksheet on this one, even if it takes me a little bit to get it done for you. If things aren't clear the first time, redraw, try again. Critical thinking is required for these. Sometimes the solutions are going to come easy, sometimes they're going to challenge you. It's hard to predict which ones. And it's one of those things that gets better, easier with practice. You'll see lots of triangles, so you'll find that they'll get easier as you go. But hopefully that gives you enough questions and gets you started on them.